This is Physics 1 Lab 3, Black Hole. Here's some things we'll be going over today. Let's start with introduction. The aim of this lab is to determine the mass of a black hole by studying the orbit of a star around it. This information is then utilized to calculate the initial velocity required for a spaceship to depart from the surface of a planet and orbit the black hole safely without colliding with the planet. This will be done with a computational model done in Glowscript. This lab also explores Newton's second law and momentum principle, as well as Newton's universal law of gravitation. Here are some formulas we'll be using for this lab. One assumption we will be making is that F net equals F grav. So where does this assumption come from? This comes from the fact that the star is solely influenced by the black hole's gravity, while the spaceship is affected by both the black hole and the planet's gravity. As you can see on the right, there's also universal gravitation formulas and Newton's second law momentum principles, as well as velocity update and position update, which will be used in the Glowscript model. But we'll get into that later. Part 1, finding mass of black hole. Here are the initial conditions for the first Glowscript model. As you can see, there's some given conditions. However, we did have to input the mass of the star, as well as the time, delta t, which is 86,400 seconds. Here's the calculation loop. For this, we inputted the formulas to find the parallel component of the force, as well as the perpendicular component of the force, in order to find the F net component of the orbit. And using all of these formulas in conjunction, we can determine the mass of the black hole using the universal gravitation formula. And so here is what is generated. As you can see, the F net vector is represented in orange. The F net parallel force was purple, and the perpendicular force is in blue. And so after that, we found that the mass of the black hole is 9.5 10 to the 33 power. So part 2, don't crash. Again, we have to set up the initial properties for this Glowscript model. As you can see, the mass of the black hole found in part 1 is inputted here. And on the right, to find the velocity of the spaceship, we find the net force on the planet, net force on the spaceship, as well as and we also utilize the velocity update formula and the position update formula here to actually show each iteration step. So after trial and error, we found this initial velocity, which gives us this trajectory, which shows that spaceship escaping the gravitational pull of the black hole. Here are some possible reasons why there could be errors in this calculation. First of all, this lab utilizes a lot of approximations, and it doesn't account for many outside forces acting on a system. There's also accuracy errors because of trial and error, which means that we can't find the exact, precise initial velocity in order to find the minimum distance between the black hole and the spaceship. Next, here are some discussion questions. How is net force and parallel perpendicular components different from the rate of change of momentum in its components? So as you can see, F net equals dp over dt. They're mathematically equivalent. However, the difference is one is easier to find than the other. F net means that you have to find all the factors exerting force on a system, while momentum is simply the change in the velocity or motion. Lastly, what initial velocity does the spaceship need to orbit the black hole? Through trial error again, this initial velocity gives us this computational model, which demonstrates the spaceship orbiting the black hole. Thank you.